This rather intriguing assembly is the control manifold or bulkhead out of the Smartap shower control system, the system that basically had 3 outlets and computer control via the internet of your shower. I thought it'd be interesting taking this bulkhead out and actually exploring it in more detail. So to start off with, I'm going to remove it from this big plastic case here, and I do see that it is well fastened in with the actual pipes that have been put in with what looks like a sort of cord. Is that hemp or is that PTFE cord? Not sure, but I'll take these out, and once they're out we can actually take a closer look at the bulkhead itself. One moment please. And we're in. I've loosened various things to make exploration easy. So these were well tightened in with what appears to be, I'm guessing this is polytetrafluoroethylene or other synthetic cord. Teflon cord, polytetrafluoroethylene. Well, actually, Teflon's just a brand name for it. So those are the main water inlets. These here are shut-off valves. I thought they were just sort of port blocks, but I don't know if I'm going to be able to show you this. The water is dripping everywhere. Where's my towel? This thing has got lots of water in it, as you'd expect, but if I shine a light, down here, down the end of that, and I rotate these, they are little ball valves. Wonder why. Are they just to shut off the manifold while you're working on it locally? Possibly for people doing service. Or it could be that it's to regulate the flow in some way other than the automated. I'm not really sure. These bits at the bottom, the outlets, these partially went through the plastic and then into that, so they don't go the full depth of the thread. And they had me a bit perplexed because these, I thought these were standard compression glands, but when you push this in, it turns out it's captive with a little ring in here. And I was wondering how they even get that in the first place until I saw the indentations at the back. This has been put in, then it's been crimped. So it's been supplied as a ready-to-fit compression-y type push-fit adapter for plastic or metal tubing. 15mm in this case, because that's a UK standard. I should put that back in there. But other than that, it is kind of a compression gland in a way. These little solenoids that control the output on this manifold, they have a little clip that holds them in. If you undo those clips, they break. The solenoid itself is actually a little valve. This is a, what do they call it when you've got the memory effect on these? There is a name for that, and now that the camera's running, I've forgotten. A remanence solenoid, that's what I'm thinking of. And this actually is a little solenoid valve in it, but this is a pilot valve. It's got a couple of O-rings here, it's got the outer layer, it's got the inner, and all it does is when the solenoid pulls in and latches, it allows a trickle of water through here that then gets amplified in here. And we'll take one of these out and we'll take a look at it. We'll take the whole manifold off. That does mean that if the thing was running when you had a power cut, I guess it must also send a pulse to these to turn them off. But if the thing crashed, it could also just actually leave the outputs on. That's a bit odd. But then again, this is theoretically going to shut off as well because the thing does use the control the motor, though that doesn't help in the case of a crash. These are half-turn ceramic valves. If I prise this off, you'll see that they're splined, standard splined tap valves. And if I get a suitable crescent wrench into this, a spanner as we call it, an adjustable spanner, a shifter is the other name in the UK. And if I undo this, we can see this is a fairly standard quarter-turn ceramic, half-turn ceramic valve, which is an end stop, and I could kind of get that out, I suppose. Can I get that out? There's the sealing ring there. Hold on, let's get this out as well then. I'll zoom in this, so you can see more details. So this little ceramic thing should lift out. And there is one ceramic half, and here's the other ceramic half. What's the little things here? Are they little wipes in some way? What are these little stems? Are they ceramic? Am I going to break it? No, they are little... I'm not sure those are. But when this rotates, it either rotates fully closed, or by regulating the amount it's open, it regulates the flow of water through it. Oh, you know what? That might be for noise reason. That might be to regulate it in a finer detail when it's at the extreme of the travel. Interesting. To avoid that horrible hiss you get. Was I even on shot for that? I think I was on shot for that. You can shout at me later if I wasn't. So we get two of those. This thing here, I'm guessing, is a spring-loaded thingy. Maybe a temperature regulator. Let's get this other one out of here. Oh, there's water. There's water dripping out. Water dripping out everywhere. This is not really surprising. We'll also take this temperature sensor block. We'll take everything apart. Oh, your water is dripping everywhere. So that's the other quarter turn valve. This thing here, when I loosened this end, just to make sure, because, you know, I think we should take everything apart, it felt very springy. It feels like there's a really powerful spring in here. Am I going to regret this? And the answer is, oh God, yes. Yes, I'm going to regret it. It just feels like it's going to open with a bang. It probably has something on it that says, do not open this. No, it doesn't actually. There's a little filter. What's in here? A little spiral thing. Not sure what that is then. Let's see if we can get the whole thing off. I'm not sure. I think this is threaded on, but I'm not really sure. If it's going to be threaded on, it might be super tight. Is this even going to fit that? Is this going to span that? No, it's not. Tell you what, I'll just pause momentarily while I undo this and we'll see if we can work out what it is. 1 moment, please. That is not coming off, but you know what? There's nothing in there really of merit. It's two spiral flutes around this on the outside. Can you see those spirals? And then I think it's the water comes in from the side and it gets mixed. I think it's just purely the mixer. It comes up to the end and then it goes through the filter and then down. And that is it. Why does it have a fancy filter though? What's the filter about? Or that might just be to cause agitation. Ooh, it bubbles and it's got grime in it. Lovely. Okay, so let's take off the sensors module here. I'll zoom out a little bit because otherwise I'm going to go way off shot, haven't I? Yes, I am. Let's get this into here. Is this just going to be a thermistor? It may just be a thermistor. This block looks expensive. It just has an expensive feel to it. Nicely engineered. Interesting stuff. Is this going to come off now? Ooh, this has just come off with these two things. But they're not really... Oh, it's got these probes that are going into the water path, maybe? Are these water sensing temperature probes? Well, there's one way to find out. We can open the thing further. It is jet black. This doesn't really help much, does it? This is actually the wrong size of screwdriver, but I don't care. Ooh, it's got a circuit board inside it. Is there something more sophisticated going on here? Blimey. Yes, there is! Jesus. Right, they're probes. Yeah, I can see. Are they thermocouples? They might be thermocouples, or are they going to be resistive sensors? This is freaking complicated. This is so much more complicated than I was expecting. Jeez. And this, there is something down here. These have like lots of connections onto them. What's that? What is it even? There is a small port, but I don't really know. I don't know what that's doing. That is strange. Is it an optical sensor? I would have thought it'd be something thermal. Don't know what that is. It's a mystery object. Although having said that, they all look gunked up. I don't know if that's supposed to be a passage through the middle. I don't know if that's a pipe through the middle. I shall gingerly poke a probe in. That's kind of hollow in that way, and it's kind of hollow in that way, and it does kind of match up with that. It's all filled with goo, actually. Yeah, not sure what that is. People who know what it is are probably saying, stop poking a probe into it. I'm not sure that is. Right, tell you what, let's get this manifold section here off. I'm pouring more water everywhere. Where's my tissue? Bit of a kitchen towel going on here. This keeps making clattering noises, as if there's something hard on it. Oh, it's the button in the shirt. Okay. Right, let's get this manifold off here. So where is my driver? I'll get this off. This is not a Linus Tech Tips ratchet driver. This is a cheap one. It works, but I've got a terrible, terrible history with ratchet drivers. They break when used with excessive force, and that happens a lot. Look how nicely machined this is. So much work went into the design of this product. For something that is was kind of slightly ill-conceived in the first place, but I suppose it's the equivalent for the Internet of Things. It's the equivalent of the audiophile industry. It's for people who just want everything to be automatic. They want to live in the future. Right, this front is coming off. There'll be O-rings that couple it on. And I think there's another machined port with a plug in it. Here. One O-ring. And these things here, what are these? These little indents are in line with that port. I don't know what that is. So this is a manifold. I'm just going to tip all the water out of it. And this manifold diverts to these solenoid valves. Let's take one of the solenoid valves out. Is this going to come out in a non-destructive manner? Is it going to come out at all, or is it just going to break? We'll find out when I try it. There is a rating in this valve. That didn't sound too good. Yeah, there's probably a special tool, especially for putting these in, because that's just crunchy plastic, isn't it? That's not coming out well. Let's use violence. More water. Okay, this is going to be messy. Let's get this out of the way first. So anything more here? We've got the water combiner or spirally whooshy thing. We've got the probe port, so it can measure. Oh, that's why there's 3 probes. There's 3 probes because it's the water in, hot water in, cold water in, or whatever it is, and then it's the water out once it's been mixed, which is this port here. So many places to leak, actually. Maybe that's why the thing was full of water. Right, is this going to go well? No, it's not going to go well. Let's get this opened up to the point it can gently crush the plastic in a destructive manner. So I shall just tighten that down, back it off a bit, open, more grip. Yeah, it's coming apart. It's rotating. Something's happening. It's not the manufacturer's recommended technique. And I just caught my fingers in between the vice grips. Vice grips, mo grips, lots of different names for them. Alright, so here's another O-ring. And here is the diaphragm system. So the water's coming in here. It's getting along the side. This here is going to be for the machining purposes. Hold on, let's take that out. This thing is stuffed with so much tech. You know, the other option, oh, this might not be coming out. This might not be coming out, but to be honest, if it doesn't come out, I'm not going to break the ratchet because, you know, I'm prone to breaking ratchets. If this isn't going to come out easily, it's not going to come out easily. They have put some thread lock in that. But I know what that is. They've machined in from the side in this. They've basically drilled a hole down here on the machine tool that's made this, and then they've threaded it and put this in to block it. But that means there's a channel down the inside of this that is, well, that's the channel there, and it then feeds up into these ports via that little slot there, and then the port activates and it lets the water flow down through here and out. So we're looking at the plastic valve. Is this going to come out? It is. It's going to be destructive, but it is going to come out. It's all full of shmoo. I wonder how old this is. I wonder how long it's been sitting wet. This is clipped in. The spudger may release this, but it may not release this. Is this actually the final bit of the puzzle? I think this is the final bit of the puzzle. But we can do a quick summary afterwards. Where's the spudger? This is going to be a long video, but I mean, can you really make it a short video when you're taking things apart? No, you can't. This isn't designed to come out. Good. It will come out, even if I have to break it out, because you know what? This isn't going back together again. Oh no, I've got one of those and I really could have done that component. Well, that's tough. This is what we do when we're being destructive. There's no way it would come out, and you know, you couldn't really use this afterwards, particularly given the solenoids in the act anyway. Right, is this going to come out? Is it going to push out from the back? Or am I going to break it by pushing out from here? There it is. What do we have? There'll be a little diaphragm in here. This is where I zoom in again. So this has a diaphragm. There's the diaphragm with the little spring and the little important wire here that goes through a hole. So if I push this through here, it can push that diaphragm up to a degree. The diaphragm is hooked over the edge. I think I'm going to have to get the spudger into this again and mop up more water, because there's water. And to be honest, MDF and water don't really go too well together. Is this complete? No, there it is. Okay. So the water pressure flows up the outside here. And because this valve, this diaphragm, normally has a little vent hole here, the water pressure equalizes either side, and because it's effectively not seeing a pressure difference either side, it's just, even though it could be 100 pounds a square inch of water, it's the same on both sides, so that diaphragm just stops the water flowing through. However, when this little solenoid valve on the top lets water in, there's a little gauze there, it allows water to bypass, and there must be somewhere to go down the middle here. But it causes a pressure differential, and that does mean that the pressure on that side is higher, and it basically pushes the diaphragm up and the water can flow by. And the reason that spring, I don't know if you even saw that, I don't even know where the spring's gone. There it is. The reason it's got this little stem here is partly to keep it in alignment, but also because every time it moves backwards and forwards, that makes sure that little hole doesn't block up. It's a sort of self-cleaning mechanism. Okay. That's more or less that. I want this gauze out now. Where's a kniff? There's a kniff. I think it's just a gauze. To stop debris going up into the superfine, yeah, it's just two ports here. One is going up to, is it actually just bypass? It isn't. I'm not really sure how it's doing that. Because where else can the water go when the little solenoid thing activates? Is it just letting water bypass? It might be just letting water bypass. Or is there a little, there's something more to this, isn't there? Oh, I see. No, I don't see. Those both are leading up to the end. Not sure. I'm not sure where it bypasses the water. Oh, it might bypass it through these little ports here. And that's how it has that amplifying effect. Oh yeah, there's a port there. And then the water flows there, and then it lets it down through there, and that's the bit that changes the equalization and allows the pressure differential. Yeah, did that make sense? Probably not. It's a very hard thing to describe verbally. But the thing about the diaphragm, the pressure on either side, and then when the pressure's equal, the diaphragm's closed. But when the pressure's different, on the other side, the diaphragm can open and the water can flow through it. That's fundamentally how it works. Anything else worth looking at? Do we look at the inside of this little thing? This is sealed shut. This has been moulded. I don't know if we're going to get this open. It doesn't look like it's going to open. What else did we not resolve? Those little ports there. There is that little thing. Is it listening to it? What is that for? What are those little things here for? This is a hole going through into the port there, the orifice. Is it to confirm when a valve has opened or not opened? At the moment, the orifice it was sensing into is the outlet. Is it the outlet? Oh no, that's the inlet. It's actually sensing. So what's the difference? Is it look at a pressure differential or something between the inlet and the outlet? Maybe that's a little diaphragm in there. That's very strange. I don't know what that's for. Is it actually monitoring pressure? Could this be a little pressure transducer? I don't know. That's very strange. Such a complicated thing. Or maybe it's actively, dynamically reacting to sudden pressure changes by it may actually say the pressure's changed, before even the temperatures varied, I'll actually start compensating, I'll run that down. That might be what it is. That's intriguing. I don't even see a number in these. Will I bend it like this? I don't know if that's really going to do much good. I don't think it's going to help much. This bit comes off. And reveals, oh God, even more circuitry underneath. Jesus. It's got so much circuitry. And that's not going off because of that. Oh, there's more chips under here. Probably serial communication. Good Lord. This is just such a complicated thing. Someone spent a lot of time designing this. But there we have it. Water inlets, built-in shut-off valve. Let me just zoom out. Water inlets, built-in ball valves, the motorised half-turn ceramic valves, the water mixer, the circuit board that senses by various probes into it. That could be thermocouples, could just be 10K probes. 10K probes would be the easiest. And then this possibly pressure sensor that I've wrecked. Then the output manifold has 3 remanence solenoids on it, 1 for each outlet. That is a complicated thing, is it not? That is an absolute monster. But there we have it, the Smartap. Very smart engineering, even if it wasn't a successful product in the long term. But well worth exploring. Very interesting device.